All right, so Carl, are you flat Earth? You round Earth? We got about 5 minutes, and I think
Round Earth. Round
yeah,
Earth. So I'll start with the easy one, right? So
you're flat Earth. You said
round.
round Earth. All right, what's your three biggest points? That's the next move.
Okay, so point number one is that spherical objects are the natural state in the universe because of gravity. So whenever you have material that sort of congregates due to gravity, right? You have one object has a little gravity, they all coagulate, so to speak, and they're going to form a sphere. That's its natural form because gravity is pulling in all directions. Therefore, it's all going to settle out into a sphere ultimately because the gravity is generated in the middle. That's number one. Number
So,
two
number
is
one is gravity causes a sphere.
correct. Yep.
All
That
right.
is the natural formation. And that's why when, even if we were on a flat Earth, we could look at the other planets and see that they are spherical.
Yeah.
Okay, so number two would be, and I might just keep it to two because you're short on time, but number two is rockets. And I build and fly rockets. I've been building.
How have you been up with the rocket?
I've been in high power rocketry since I was a kid, and I'm actually working on two rockets now that I'm going to fly next month. So,
What is your goal? What height do you want them to get to?
well, we're only allowed to fly due to the FAA clearance, but we can go up to 13,500 feet.
Okay.
And I usually get real close to that just about every flight these days.
That's awesome.
Yeah, it's super fun, and it really scratches a lot of itches. It requires a lot of disciplines and skills that you have to develop. It's a really good hobby.
Okay.
Anyway, so let's just start with it kind of already explained, but the spherical objects that we see, stars are spherical.
Yeah.
The moons are spherical. The planets are spherical.
It seems very obvious that we should be on around Earth. Then. I mean,
Right, and so therefore, why wouldn't the Earth be spherical? But the reason for that is, as I explained, objects, supposedly at the creation of the universe, even small objects have gravity. It's just very indetectable. Gravity is a relatively weak force for that reason. So, but so two objects, they come together. Now you have a little more gravity, then it pulls in another piece of dust or a rock, and then you have more gravity, more gravity, more gravity. But the gravity is all directed equally from into the center, so that way the objects are always going to kind of, when they connect, are going to naturally want to form a sphere, not a flat disk of any kind.
Yeah, no, I definitely agree with that. And if those are just a couple points that you want to mention, is there anything else?
Oh, well, the rocket thing I want to mention is that you do not, the rocket exhaust does not need to push against anything, right? So it's Newton's third law.
Yeah, equal and opposite reaction.
A simple experiment you can do is to stand on a skateboard that's stationary, right? And if you were to pick up a cinder block, and you got to be careful because your balance is going to shift, but you can literally do this. You pick up a cinder block and kind of swing it and throw it behind you. So what happens when you do that? Your skateboard is going to move forward.
Exactly.
Every time. And that cinder block did not have to push anything because it's disconnected from you as soon as you release it. It was the motion of that mass being tossed behind you. The equal and opposite reaction is what is pushing you forward. So the exhaust doesn't have to push against anything. It's the mass of the exhaust leaving the rocket in one direction at high velocity, and you're getting the equal reaction pushing it forward. It's not pushing against anything. And and I'll finish with this.
Okay.
The vacuum rocket situation, right? I saw that experiment. All it was is a very, very, very low thrust form of a rocket motor. It was technically a rocket motor. Very low thrust, almost like lighting a match.
Like a cat.
So it just takes a little bit for the inertia to kick in. So there's a short delay as that minor amount of thrust starts pushing a much larger object.
Definitely.
In other words, the thrust to weight ratio was almost even. It just had the thrust had a slight advantage. So therefore the acceleration is very slow, and so it looks like it's waiting for the plume to hit the sidewall when in fact it's just the lack of thrust.
Yeah, but even in a vacuum or even space, that a rocket engine, when it propels itself and pushes the gases out the back of the rocket,
Right.
it pushes the rocket forward.
It's the mass of the exhaust. So the fuel is converted to gas through burning. It expands very rapidly, but it's still mass. It has mass.
The mass of the expanding rocket pushes the rocket.
Right. So the velocity, really the velocity going out the back, you expand it so that you can force it out.
Yeah, but you're moving something.
Exactly. And it's the velocity of the exhaust
Yeah.
that is pushing, not anything to do with interacting with any atmosphere around it.
Well, awesome. Well, Carl Robinson, man, you had some great points. I hope your dog walk is going well.
It is.
Typically on the Dan
This was
Live
fun. I
show,
appreciate you having me on.
yeah, typically on the Dan Live show, we always ask for somebody's final words to the chat. So, do you have any?
Yeah, I do. I would say to any flat earthers, respectfully, that all of these theories of a spherical round Earth have been tested and tested and tested again. And all of the findings, the scientific findings, the mathematical findings are available. They are there. They exist. They have yet to be disproven. So, you tend to find these arguments where you can't really pin them down. You try to pin them down on one thing and they just come up with something else like whack-a-mole. But
Yeah.
the bottom line is seek and you will find.
Seeking you will find.
All of the evidence for a round Earth is there. It already exists. It is irrefutable. That's it.
Awesome. Well, awesome last words, Carl Robinson. I appreciate it. If you don't mind, like and share and come on back. Thanks for being.
I'm gonna follow you right now, and I'm gonna look forward to your next one.
Well, you're our final guest on the Dan Live show. I appreciate it, man.
All right.
Good evening.
Well, I appreciate it, man. It's like in fireworks. It's the grand finale.
Oh yeah, come on. All right, it was good arguments. Thank you, Carl. You have a good night.
You're welcome. Appreciate it.
All right, guys. So that was our final guest on the Dan Live show. This has been a great show. Let's just be real about it. So initially, I mean, everybody was shy to get on, but we had a bunch of great guests. We had a flat earther, and then I got trolled. The second one I got trolled. We had a British person come in boxing. He had some great points, and boxing was just absolutely completely passionate, and I really appreciate it. And we had some really good round earthers too. It's been a great show. It really has. But I do have to keep it to an hour at a time right now. I definitely have to finish the rest of my day. But if you don't mind liking and sharing and staying tuned, we're going to do this as we can every day, weekday, mostly between, like 4 p.m. Central Standard and 6 p.m. Central Time, 4 p.m., 6 p.m. Central Time here in America, right? We're going to be doing the Dan Live show. We're caller based. Let's call out to all the people. Paul Haggerty, Steve Schreiner, get in on the next one. Richard Shimpley, John Regas. We have so many people wanting to join. El Marino, El De La Pascas, Les Skinner, Bill Smith, Contrary Warrior, Stacy Viles, John Rodriguez, Richard Sipley, Yo User. We had so many people wanting to join. I'm so sorry we couldn't get to it. But thank you so much, everybody, for Dan Live, right? And thanks for joining. Thanks for reacting. If everybody just joins next time, and just see when I go live. We're going to shoot for tomorrow between 4 and 6 p.m. Thanks for the love, everybody. Come on back and stay curious.